Let's dive into the fascinating topic of the vesiculation of the neural tube. So over here you can see a neural tube which is cylindrical in shape, and it is open at the cranial as well as the caudal end. The cranial end being called the anterior neuropore, whereas the caudal end is called as the posterior neuropore. Now there are two theories for the closure of the neural tube. One is the zipper theory, the zipper line theory, which says that the first closure happens around the fifth somite level, and then it, like a zip, it will be closing both cranially as well as caudally. The other theory is that is the multi-site theory, which says that there are 5 sites, 1, 2, 3, 4 and 5 sites, and they will be closing, and then further closure will be happening adjacent to these sites. So these are 2 sites. Today we are concerned that after the closure of the neural tube, which we can see in this model, you can see the neural tube is totally closed. But if you see in the cranial end, it is having certain enlargements or certain balloonings are happening this, and this process is known as the vesiculations, and this will be I will be explaining through the models. So this is the first model, and we are actually seeing this section. So see, this is your neural tube and we are seeing this section. Okay, this is the section of the neural tube we are appreciating. So this will be your ventral portion and this will be your dorsal portion. So we can see various dilatations and certain flexures. The first flexure is known as the mesencephalic flexure, which will be occurring at the mesencephalon region. Now there are 3 dilatations. This is a 3-vesicular stage. The first being the prosencephalon, the second being the mesencephalon, and this one is the rhombencephalon. And this rhombencephalon is separated from the spinal cord by a flexure that is known as the cervical flexure. And over the rhombencephalon, you can appreciate 2 neuromeres. And these neuromeres are of the nerves, the first being of the nerve trigeminal nerve and the other of the acoustic facial nerve. Now acoustic nerve corresponds is a synonym of vestibulocochlear nerve. In the prosencephalon region, you can see a lining or a sulcus. This is known as the optic sulcus, which as the development progress will be converting into the optic vesicle. In the second model, you can appreciate that the flexures have accentuated more and the vesicles are much more defined now. So again, this is your mesencephalic flexure, the cervical flexure, and this is your prosencephalon, and the optic vesicle is now invaginated to form a cup that is known as the optic cup. So this is your prosencephalon, the optic cup, the mesencephalon, the rhombencephalon, having the 2 neuromeres of the trigeminal nerve and the acoustic facial nerve, and this one is the spinal cord. With further enlargement of the vesicles, you can see the optic cup is now narrowed down. It has reduced in side, but it is more of elongated in structure because eventually it will be forming optic stalk. So this, you can see the optic cup has reduced in size. This is the prosencephalon, the mesencephalon, the rhombencephalon, and this mesencephalon and the rhombencephalon are getting separated by a constricted region that is known as the isthmus. This region is known as the isthmus. Also, there is appearance of another flexure, but this time it is on the dorsal side, and this flexure is known as the pontine flexure, which will be actually separating your rhombencephalon into mesencephalon and the myelencephalon in further stages. So now you can see the optic cup can't be seen because now it has been elongated to form the optic stalk, and over here is the this is actually a 5-vesicular stage. Initially, we were seeing the 3-vesicular stage, namely the Prosencephalon, Mesencephalon, and the Rhombencephalon. But over here, you are able to see the telencephalon. See, this is your telencephalic vesicle. Then you are able to see the diencephalon region. Then this is the mesencephalon region. Then this is the pontine flexure. Okay, this is the pontine flexure, which I've told you will separate your rhombencephalon into metencephalon and the myelencephalon. And this is the neuromere for the trigeminal nerve, the neuromere for the facial nerve, and the neuromere for the acoustic nerve or the vestibulocochlear nerve. In this model, you can clearly appreciate the 5 vesicles: the telencephalon, the diencephalon, the mesencephalon, the metencephalon, and the myelencephalon. And these are the nerves. The optic nerve, this is optic nerve, the optic stalk has elongated to form the optic nerve. The trigeminal nerve, the facial nerve, the vestibulocochlear nerve, the vagus nerve, and the glossopharyngeal nerve. And this pontine flexure is actually the site for the emergence of the 4th ventricle. And this metencephalon will actually, the roof of the metencephalon will be getting thinned out, and it will be extending laterally to form a structure that is known as the primitive cerebellum. So we know that your metencephalon is forming pons and cerebellum. So pons obviously will be situated in the ventral side, and cerebellum is situated on the lateral and behind surface. And this region will be the 4th ventricle. And this is the myelencephalon, which will be forming the future medulla oblongata. So this over here we can see that the telencephalon is growing fast, and it is actually covering the lateral region, the anterior region. It is going also behind. So it is actually pushing the diencephalon in the medial region. And then we are having the mesencephalon. So this being the mesencephalon. And over here you can see this is the extraventricular part of the cerebellum, and this one will be the intraventricular part of the cerebellum. And this will be the future pons, and this one will be the medulla oblongata. Over here we can see that the telencephalon has formed the cerebral hemispheres, and this region is known as the insular area.